Previously, what are the reference frame we discussed?
Right ascension.
Huh?
Right ascension.
Right. So, do you see the right ascension system here? Yes. Alright, now pay attention, okay? You definitely see the ECI system. First of all, there are two planes. Do you see two planes? What are the two planes?
The horizontal plane, the plane of the Earth's.
Why is it parachute?
You got the satellite.
Always understand, planes are what? Perigee is what?
The
What is perigee?
I'm sorry.
Mathematically,
You got like the plane for the.
it's a point.
like
So the y plane in the vernal equinox. Where am I?
What is a plane? This is very serious. Is y a plane?
No.
no,
Anthony, what is y?
It's a line.
Yes. So distinguish between point, line and plane. 2 points form a
Point.
huh? 2 points form a
alpha.
what is omega and alpha? What are they? Is that a plane? Angles. When try to understand the basic terms in mathematics or geometry. What do you need for two planes?
Two axes.
Two axes.
Right.
Two axes will form a plane. Okay, the area between the two axes. For example,
Axis X and axis Y.
yeah, that will form a plane. Y and Z will form a plane. You cannot say Y plane. There is no Y plane. There is Y axis or Y line. Okay, you cannot say perigee line. Perigee is a point. All right. 2 points when joined form a line. 2 lines form a plane. You can also that it also gives a sense for angle. Okay. There are 2 planes here.
Is that
This is the first plane.
that green?
So it's
What is this plane?
X, Y.
Equatorial plane. Okay. How do you define a plane?
With 2 axes.
2 axis or
Or 2.
pay attention here, guys. Put your cell phones away, please. The perpendicular to a plane defines the plane. Does that make sense? The perpendicular to a plane defines the plane. Does that make sense? How would you define this plane? What is perpendicular to this plane?
Z axis.
Z-axis. So Z-axis is will define that plane. Okay. What is the plane itself? It's the XY plane, but it is defined by Z-axis. Does that make sense? How is this plane defined? What is this plane? Anybody?
Based on the Earth axis.
The R.
How do you define that plane? Define. This plane is defined by
H.
Z. Okay? This plane is defined by H. Got it? And does that make sense? This is the orbital plane. Got it?
Yeah.
So if you look at what is at the center, what is the origin of this plane? You see there are 2 reference frames here. Do you see the ECI or the equatorial reference frame? There is the z-axis. What is the z-axis? Anybody?
It's the active, so,
What is z-axis?
this,
It's the axis of rotation of Earth. Okay. What is this direction? The vernal equinox. Remember, we defined this axis, this direction. Okay. And that y direction completes z cross x. These three axes together form the geocentric equatorial frame. What is at the origin of this frame?
Oh god.
Focus.
Or sorry, the focus, yes.
Foci is 2. Okay. Focus. Okay. So you see the orbit around it. That's how any orbiting body is going. It will always go in a plane unless it is disturbed. You saw that with your presentation as well, right? In the presentation on Monday. Okay. So where is the orbiting body right now? Do you see the orbiting body? Yeah, satellites. You see that circle or sphere? That's the orbiting body. Okay, that is the current position. You understand? But it is going to go like this. It's going to keep on going in that orbit. All right. So you understand the equatorial plane and so if this is the equatorial plane, this is the orbital plane. Got it? Where do two planes intersect?
Sorry.
Where do two planes intersect?
Two. Line.
Where do two lines intersect?
Or not.
No. Where do two lines intersect if they intersect? At a point. Does that make sense? Can two lines intersect at another line?
both. It's always intersect.
Two lines will always intersect at a point, or the intersection of two lines is a point. Similarly, the intersection of two planes is a.
It's a line.
It's a line. You got it? That's simple, right? If you intersect two planes, what are you going to get? You get a line.
Okay, so where these 2 points intersect would be the vernal equinox.
Vernal equinox is a direction.
I see. Okay. Sorry.
Okay. Where is can you see the line where those two intersect?
Isn't the line like right there at
The line of nodes.
Line of nodes. You see, this plane, this line is where they intersect, through and through. You get it? That's a line of nodes. Okay? What is happening here from this point forward? It's ascending. Does that make sense?
Yeah.
It's going. So this half is what? The northern hemisphere.
Okay.
Yeah.
The bottom part is the
Southern.
southern hemisphere. So at this point, until this point, this is where the two planes intersect. This plane and this line of nodes. Okay. This is called the ascending node. Why so?
Because it's climbing.
It's climbing. From this point onwards, if you assume the direction of orbit is like this point onwards it will ascend, it will go to, so the equatorial plane is like this, okay? This is the orbit. You understand? That line, this point, from this point forward, the satellite is going to go like this. It's ascending, right? Earth is like this. This point will be descending. Does that make sense? It is coming down. So the satellite is going like this. You get it? This is the ascending node and this is the descending node. Does that make sense? Yeah. Can you orbit, so if this is the Earth, can you orbit like this?
No.
Can you orbit like this?
No.
No.
It has to always do this. This has to be at the center. Keep in mind. You cannot just orbit in a separate plane which does not intersect with the Bakari.
Yes.
Keep your close your lid. You cannot have a orbital plane which does not intersect with the equatorial plane. Does that make sense?
Yes, sir.
It has to intersect with the equatorial plane. Got it? Because where is at this the center of this line is what? Center of line of nodes is what?
The center of line, right?
It's the. It's the
Center of line of nodes.
It's the place where the two planes intersect, right?
But that is what the line is. But what is the center of line of nodes? One word. Huh?
You said the center of line of node.
Yeah. So line of nodes is from this line, this point to that point, right? It's from the ascending point to the descending point. What is at the center?
The core, the center.
It's at the focus. It's the focus. You get it? Yeah. Now, what you need to know is
I thought the focus was for the list for the two.
this. Just look at this, guys. If I look from the top, from that Z point, this is the top view. This is what I've been drawing all this time. You guys, okay? What is this? What you see, this line I was talking about. This is the line of nodes. Okay? This is the
Focus.
focus. You got it? This is the x-axis or the vernal equinox direction. This is not the y-axis actually. Where is the z-axis? The z-axis is not shown here. What plane is this, guys?
That's the equatorial, equatorial planes.
Is this the equatorial plane?
No, it's the Z. Or right.
That's the order.
That's the orbital plane. So the view is from, and my apologies, the view is from, where is this view from? H. It is from H. You got it? So that, huh?
It's from H, not Z.
Yeah.
Do you see H as Z?
Yeah, I'm saying the view, the next picture, the view is from H, or is it from
H.
So H is perpendicular to the orbital plane.
Orbital plane.
And H is denoting what?
H is what?
H is,
The orbital plane.
H defines,
H defines the orbital plane, but what is H?
It's
Small h.
Angular momentum.
Specific angular momentum. Okay. So what it means is, what do you know about specific angular momentum? It's conserved, yes. So what it means is, pay attention here, guys. This is very important. This is what it's conserved means. If the age increases, what happens to the plane? It gets bigger. You see?
So as age increases, the planes.
It means the a plane. Yeah, you indicate if you have. So what can increase or decrease of age? The magnitude can increase, right? The direction can change. You right? Yeah, you understand?
how does the plane? I mean, how
Age is an indication of age, the plane or size of the orbit. If the age becomes, so only the magnitude increases. What happens to the plane, the orbit? Becomes bigger, bigger, bigger. But the plane is the same.
Okay.
Does that make sense? If the direction changes, what is the direction of age for an equatorial orbit?
Orbiting the equator.
What is the direction of age orbiting the equator? Yes.
Z.
Z, yes. H is Z that time. You got it? It aligns and the orbit is that. So when H goes on increasing, the equatorial orbit becomes bigger. You got it? That is how you indicate bigger orbit. Alright? If H is perpendicular to Z, what orbit is that?
Polar.
Yes, polar orbit. You got it? So if you do that, then it will do this. You see, this direction is very, very critical. This is also Earth's rotation. This is also orbiting rotation, orbiting direction. You see, here, see if this makes sense. You know, this is how Earth is going, right?
Yeah.
This is how the satellite is going. Does that make sense? This is the direction, right? Satellite.
Yeah.
So you can indicate it by H. So that's the reason I said the perpendicular to a plane defines the plane. There is no other way of defining a plane. How else would you define an infinite plane? How would you define this plane if it did not have any edges? Huh?
Oh, besides the.
Yeah, that's what I told you just now. The perpendicular to that plane will define the plane. The plane is infinite now if you define the perpendicular. You understand? If I say this, can this plane have more than one perpendicular?
Yeah. Well, if it's
No.
It is either this or this, but it is always this direction, right? It is this perpendicular which is going through and through. That is the only perpendicular. You understand? There are no two planes perpendicular for a given plane. Everybody agrees? There's only one perpendicular, right? It is going to go through. That defines the plane itself. So here, this Z defines the equatorial plane. Got it? It is also called Z is also called the
No, the axis.
axis of rotation. H defines the orbital plane. It will also be called the axis of the orbiting point. Does that make sense? So this Keplerian orbits which follow Keplerian laws, are always plane. Only if you add some thrusting to it, it will change the plane. If something is in a plane, it will keep doing that. The size will be the same, the direction will be the same. So the H is, that is what H is. R cross. So R is where is R? In that plane, right? The velocity is also in that plane because it is not leaving the plane. So if your R and V are in that plane, R cross V has to be perpendicular. R cross V is H. You get it? So R conserved means, H is conserved means that plane is always the same. Does that make sense? So equatorial plane, does it change?
No.
It won't change, right? So only if Earth did something, this thing, and then that would change. But the equatorial plane is the same. It's always, what is the inclination of the equatorial plane with the, what is, you know something, there is this 23.5 degrees, right? Everybody has heard about that?
Yeah.
What is that 23.5 degrees?
That's like
It's the.
Tilt. So how do you define that? What an angle is what? How do you define an angle?
difference between the two lines.
Yeah, it's a distance.
It is,
Or
yeah, it is between two lines, right? What are those two lines?
axis of rotation.
Axis of rotation and orbiting axis.
Yeah.
So the Earth is rotating in this, let's say this is the Earth's rotating orbit, okay? Or the orbiting around the sun. This is the axis. This is the axis of rotation. The angle between these two is 23.5 degrees. That is the tilt. What is the consequence of tilt?
The consequence of what?
Tilt.
In terms of.
What is the consequence of tilt?
Ascension.
Huh? Consequence.
Oh,
I would, and I took Lord.
you say something like this is bad, like consequence.
Yeah, there is a consequence, right?
Well, like, doesn't it mean like the poles or something like that?
No, it's the consequence of rotation is poles.
Right.
What is the consequence of tilt?
Like,
What are the consequences of tilt, or what is the consequence of tilt?
Like forcing
Seasons.
We were
Sorry, I did not hear.
the way you're phrasing it,
Season.
I thought you mean like mess up the orbit or something.
The consequence of tilt is seasons. You get it? Because when it is tilting, when the northern hemisphere is facing sun, there's a tilt, right? It's summer.
Right.
It goes this way, the southern hemisphere is facing sun. The northern hemisphere is facing away from the sun. The southern hemisphere that is summer. That is the consequence of tilt. Got it? Now, any orbit you have to, all orbits are unique. Okay? And there are 6 elements which make up the uniqueness. That's what you have to learn from here, and that's what is going to be a big part of your next test. Okay? We have already discussed 2 of these unique elements. First one is A or H. What does this define? What is A?
The axis.
Small a.
Semi-major.
Semi-major axis. You got it? So the semi-major axis, if the semi-major axis is big, it means the size of the orbit is big, right? This defines the size, H or A. This defines the size of the orbit. Got it? E defines
The shape. The shape.
the shape of the orbit. Now, since Michael brought up something, I want to say what defines the orbit?
Just define the order.
The perpendicular.
6 elements.
That is what we are exactly discussing now. Got it? So don't tell me this defines the orbit. This defines the size of the orbit. This defines the shape of the orbit. You got it? How many more elements are there? 4 more. Okay, yes.
Okay, so you said that H defined
The size of the orbit. H or A.
Oh, serious.
Yes.
I'm going ahead and point out.
Okay,
So the plane is the same, right? But if the magnitude of H increases, the plane will become bigger and bigger. Let's say E, for a given E, let's say E equal to 0. What is the shape of the orbit? Circular, right? So for that same circular orbit, if the H becomes big or small, the circle becomes big or small.
So you say it should be H bar.
Huh? It should not be H bar. It is, all these are scalars.
So is H inversely or directly proportional to the size? So
Directly proportional. Directly proportional.
Okay.
Are you saying A or H?
A or H. Yeah.
A or H.
A or H. Because both are, you know, A and H are connected by what? You remember this, right?
Yeah.
E square. Okay. So for a given E, that's what I was talking about. Mu is always constant this is a constant of the central body, right? If for E, for a given E, H is proportional to A, or A is proportional to the square of, you can write A is proportional to H square for a given E. You understand? So you can use interchangeably, you can use these.
Does the total mechanical energy define the size and shape, or you're not including that?
Total mechanical energy is different.
Leave that one alone.
Yeah, we'll talk about that. Okay. But these two are
All right, man.
You turn your laptop to show that.
Huh?
You turn your laptop to show that on the board.
I want to show you guys this. Okay. This you can just note it down. What is the next one? So look at this. What angle is this? Anybody? It is alpha. It is similar to alpha.
Oh,
You get it?
That's okay.
It is similar to alpha. It is right ascension. The angle, this angle is between the vernal equinox and the line of node or the ascending node. Specifically ascending node. It is called the omega is called the, so this you'll hear a lot. The short is RAN. It's called right ascension of ascending node. Yes. Okay.
So we
What plane is this angle in?
what line is there?
What plane? It is in the equatorial plane.
Are we going to use omega or are we going to use alpha for it?
Omega.
Okay.
Okay. Alpha is only right ascension. This is the right ascension of ascending node. You got it?
What does that help us with?
Huh?
What does that help you with?
So it tells you, it depends on where this intersection is. Okay, where the plane intersects, or when it is going to be on the northern hemisphere. This is the ascending node. It's going to tell you when the satellite is going to go into the northern hemisphere. Can you see something in the southern hemisphere? Unless you have a huge field of view, any orbiting body in the southern hemisphere, you cannot see.
Okay.
Okay? So this is one angle, alright? There is another angle here. I is the inclination. Now see if you can, we already defined this. What is this inclination angle? The inclination of the orbit with respect to the equatorial plane. What, in other words,
What's our
Huh?
the
the tilt. Yes. So for Earth it is fixed, but for satellites, depending on where you launch the satellite, that can change, right? For different satellites it is different. What is this angle between? How is angle defined?
It's between A and B.
Yes.
Yep.
Angle between H and Z.
But inclination refers to as tilt or is it not something? Did you say that inclination is tilt or?
Inclination is tilt.
Okay.
But what we classically understand is the tilt of the Earth. So what is the tilt of the Earth? Is that inclination?
Yes. I mean,
Is it
Huh? What would the inclination of Earth be? How would you define the inclination of, or inclination of Earth? Yes, tell me.
23 degrees.
That is the tilt. But what is the inclination? How would you define tilt of the, or inclination of the Earth?
The angle of rotation, or yeah, the same thing.
You would have to look at the axis of rotation of
Earth.
Sun first.
Axis of rotation.
Sun. And then the orbiting axis of Earth. It doesn't matter how the satellite is rotating for inclination.
How do you find the axis of rotation of the sun? Like, what does that have with respect to?
It's
But what planet?
Earth will be rotating. Everything is rotating, right? Is there anything which is not rotating?
No. Like,
Huh?
well, yes.
Asteroids? Any of the planets are non-rotating?
You're saying the sun's rotating?
Sun's rotating as well.
I'm saying, like, how do you know?
Stars.
I'm saying, how do you know?
Tilt with respect to what?
Is it the galaxy or the? That's what I'm asking. How do you define like how the sun is tilted? Like, says
Sun, we don't know the tilt of the sun.
So we're saying it's 23.5 with respect to
Earth's tilt is 23.5 degrees with respect to sun. But we don't know, we cannot reference sun with respect to anything.
That's why it's in.
Huh?
what about like with the
Our solar system is probably, so what is at the center? Sun, right?
Yeah.
That is what your understanding is. That is what you have been told. Right?
I don't know.
Solar systems are centered around
Stars. It says orbits of the galaxy.
Stars.
Sun.
Solar system.
So what's the stars?
solar refers to solar systems are centered around stars, okay? Our star is the sun. Solar systems can a bunch of solar systems will make
The galaxy.
galaxy. What is at the center of the galaxy?
Black hole.
Probably a black hole.
Yeah.
Multiple galaxies will form.
Saves the book.
Multiple galaxies will form
The universe.
universe.
Okay.
What is at the center of the universe?
Good question.
God knows. Because we don't know what is the extent of the universe.
It goes on forever.
Okay. So we have to look back into sun. Can we reference sun with respect to something? We don't do that in Newtonian mechanics. With Newtonian mechanics, we are very happy being in our solar system. We don't get out of the solar system. Okay? Got it? So this inclination is clear. It's the angle between these two vectors. Okay? Now there is another angle. It's called the argument of periapsis. Okay. You see this angle, the small omega. What is this direction? What is this direction?
That's the
Perigee direction. What is how do you define the perigee direction?
It's the point at which it is closest to the focus.
What is the direction? What do you need for direction?
I'm not even able.
Huh?
Okay. What goes on?
Do you need a direction? Do you need an angle for a direction? What do you need for a direction? 2 points. So what are the 2 points for perigee?
The focus and the point at which it's close that.
The perigee itself. The perigee direction is the line joining the focus and the perigee. That is the perigee direction. So if you extend that, that is the perigee axis. You got it? Are there multiple perigees? There are always only one perigee. You got it? Regardless of what orbit it is, even for a circular orbit, once you define a perigee, that is your perigee. Does that make sense? Okay. So perigee is what? A point. Perigee direction is what? A line. You have to make sense. Okay. Now the argument of perigee is what? An angle. An angle is between two lines. What are the two lines here? The line of node and the perigee direction. You got it? What plane is this angle in?
The
Orbital plane. So you see this angle is in the
empty.
equatorial plane.
Yes.
This angle is in the orbital plane. This angle is the angle between those two planes. You get it? So this defines these three define the orientation of the orbit. Okay? And finally, you have theta. Here it is represented by that, yeah, V naught or eta naught. Okay? This is the
So this is between your period direction and
true anomaly. What is true anomaly again?
is
An angle. So if you see what is true anomaly, it's the angle between the perigee direction and the wherever the satellite position is. Okay? So this is what keeps changing. Alright? These 6, 1, 2, these are grouped into, first is the size and shape of the orbit, second group is the orientation of the orbit, third is the relative position of the satellite with respect to the,
I keep forgetting the name of that.
Wait, that divided by B or that or
or so we'll use theta. Okay, here it is represented by this eta naught. Okay, how do you the position? True anomaly is a position, right? What is it defined with respect to? Perigee direction, always. Okay, this is an angle. So this is an angle. This is an angle. This is an angle. This is an angle. This is a distance. Okay, this is a ratio. Right? Size, shape, orientation, position. These 6 define an orbit uniquely. Yes.
That's the relative position of the satellite with respect to what?
Perigee direction. So the basis for this is you have to establish 2 reference frames. The first reference frame here is the equatorial, geocentric equatorial frame. The second reference frame I did not discuss. I'm going to discuss that now. The second reference frame is called the PQW frame or the perifocal frame. What is the P direction here? Perigee direction, okay? What is W? Any guesses for W?
is it the
Is an argument of
direction of the
Direction. Angle is not. Any guesses for W?
is it the direction of
What does not change?
what is not
That's what I'm asking you.
or satellite or
In life.
The orbit itself.
Huh?
The orbit itself doesn't change.
How is that indicated? What did we just say?
you just said
If an orbit does not change,
then
how do you represent that? H is conserved means orbit does not change. Okay, so this is the H direction. H does not change, right? And what is Q? Any guesses? This is very similar to the ijk axis. Okay, what is the k axis? Z, right? What is this? Axis of rotation. What is x or what is I? X. What is this direction? Vernal equinox. And J is simply Y, which is Z cross X. You need at least two unique directions to define a reference frame. These are the two unique directions for here and here. The third is simply completes the right-handed coordinate system. Alright, any questions? You're good? This will be a major part of your this and the things we have discussed in the last week will be your next, the topic of your next exam, okay?
Will that be?
Yes, so when do you want it?